Good morning, students. Once again, welcome to the AP Residential Schools. My name is J. Jansi Rani. I am working as a PGT Mathematics in AP Residential School, Nagireddigudem. In the previous class, we have discussed about the definition of the rational numbers and also the properties of the rational numbers. Today, in this class, we are going to discuss about the representation of the rational numbers on the number line. Let us see. Here see this one of the number line is there. So which type of numbers are there on this number line here? We are having 0, 1, 2, 3, 4, 5, 6 and so on. So these are all whole numbers. Okay. So we can represent the whole numbers or natural numbers on the number line. So in this number line, what are the numbers between 1 and 5 here? Yeah. Between 1 and 5 we are having the numbers 2, 3, 4. Is it correct or not? And next, see this. Here we are having the integers on the number line. Now, so we are having integers. Integers means we are having on the right side of the 0 all the positive numbers, on the left side of the 0 on all the negative numbers. Now what are the integers in between -1 and 3? Here we are having 0, 1, 2 in between -1 and 3. Is it correct or not? Now what are the numbers in between 0 and 1? Is there any integer in between 0 and 1? Can you say? No, because there is no integer between 0 and 1. But there is a number, there is a rational number in between 0 and 1. Is it correct or not? So let us see what are the numbers between 0 and 1 we are having. We know the number between 0 and 1 is half, that is 1 by 2. Is it correct or not? In the same way, we are having between 1 and 2 we are having the number 1 and half. Is it correct or not? Here 1 and half means 3 by 2. Yes, between 1 and 2 we are having the number 3 by 2. In the same way, between 2 and 3 we are having the number 2 and half, that is 5 by 2. Like this, these rational numbers also we can represent on the number line. Let us see how to represent. Okay, see this one here, between 0 and 1, so we are having the number half, that means 1 by 2. We can represent on the number line like this. And between 1 and 2 we are having the number 3 by 2. And between 0 and -1 we are having -1 by 2. Between -1 and -2 we are having the number -3 by 2. So like this we can represent the rational numbers on the number line. So let us go for the one more example. Here there is a number line. Here the space between 0 and 7, that means 0 and 1, is divided into 7 equal parts. Okay, and here the letter A indicates, see this one, here the space between 0 and 1 is divided into 7 equal parts. The first part is 0 by 7, next it is 1 by 7, and it is 2 by 7, this is 3 by 7, and this is 4 by 7, and this is 5 by 7, and this is 6 by 7. Here the letter A indicates the position of A is the second part, it is second part, and out of 7 parts we are representing the second part. So this rational number on the number line is 2 by 7, and the letter B indicates 4 by 7. Okay, in a rational number the denominator indicates the total number of equal parts and the numerator indicates the how many parts we are selected. Number of selected parts. So in this way we can represent any of the rational number on the number line. Now let us see one more example. How to represent 3 by 8 on the number line. To represent this number on the number line, first of all we have to draw a number line and we have to identify this number is in between which integers are there. So here we have to divide 3 with 8. So the answer is some 0 point something. That means this value is in between 0 and 1. And also we learnt here, that is the denominator indicates the total number of equal parts. So here the denominator is 8. So we have to divide the space between 0 and 1 is into 8 equal parts. So this is 8 by 8 which is equal to 1. So divide it into 8 equal parts. 1, 2, 3, 4, 5, 6, 7 and 8. Let us see. Now this is 1 by 8, 2 by 8, 3 by 8, 4 by 8, 5 by 8, 6 by 8, 7 by 8 and it is 8 by 8, that is equal to 1. So here we have to divide the space between 0 and 1 into the 8 equal parts and we have to represent 3 by 8. Now just round up 3 by 8 on this number line. So this is the way to represent the rational numbers on the number line. Here the value of this number is in between 0 and 1. If the value is more than 1 or more than 2 or more than 3, how to represent that one on the number line? Let us see. Now let us see the number. How to represent this 26 by 9 on the number line. So first of all, do the division. 26 is dividing with 9. Okay, we know that 9 2s are 18 and 9 3s are 27. It is more than 26. So take 2 times. And this is 16 minus 8 is 8. That means its value is 2 8 by 9. So this indicates this 26 by 9 is this is more than 2 but it is less than 3. So we have to take the number 2 here and number 3 and the denominator is 9. So divide the space between 2 and 3 into 9 equal parts. 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, here it is 2 and it is 3. This is 2 1 by 9, 2 2 by 9, 2 3 by 9 and 2 4 by 9, 2 5 by 9, 2 6 by 9, 7 by 9 and 8 by 9. So we have to represent this 26 by 9, that is 2 8 by 9 on the number line like this. Okay, understand the concept how to represent the given rational number on the number line. Okay, now let us do a small activity. See this one. Now let us see the activity. There is a number line. Here we are having 0 by 5, 1 by 5. Now then what is the letter A indicates here? The letter A indicates, yes, it is 2 by 5. What is B indicates? And here B indicates 3 by 5. Then what is C? C is equal to 5 by 5, which is equal to 1. Then what is D? D is 6 by 5. So, have you understand how to represent the rational numbers on the number line? Now, let us see this one, the second one. Here we are having a number line. Here the first number is minus 7 by 4 and it is minus 1 and it is minus 2 by 4 and minus 1 by 4. So, what are the numbers we have to insert in place of this question marks? See this one. Here the space between two numbers is dividing into 4 equal parts because the denominator indicates the how many equal parts are there, the denominator will indicate. So, can I write this minus 1 as minus 4 by 4? Is it correct? Yes, it is correct. So, now what is this? This is minus 6 by 4. And the next question mark is minus 5 by 4. Like that. And this is this question mark will give us minus 1 by 4. Sorry, this is minus 3 by 4 and next one is minus 2 by 4 and minus 1 by 4. Okay, in this way we can represent the rational numbers on the number line. Let us go for the another topic, that is how to find out a rational number in between two rational numbers. So now we are discussing about the rational numbers between two rational numbers. Okay, so if you are taken sum of the natural numbers, that is 3 and 7. So what are the natural numbers between 3 and 7? We are having 4, 5, 6 in between 3 and 7. Is it correct or not? Now the integers between minus 1 and 4. What are the integers between minus 1 and 4? Yes, we know that is 0, 1, 2, 3. Okay. Then what are the integers between minus 1 and 0? Is there any integer between minus 1 and 0? Or 0 and 1? Is there any integer? Can you say? There is no integer between any two successive integers. Is it correct or not? But we can write there is a rational number between two rational numbers. So, we can write the rational numbers between any two rational numbers. Let us see one example. Take two rational numbers 2 and 3. So, what is the rational number in between 2 and 3? How to find out? Okay. So, yes, we can find out by using a small formula. What is that formula? If A and B are any two rational numbers, then the rational number between A and B is equal to A plus B by 2. That is which is nothing but the average of given two numbers. The average of given two numbers or the mean of given two numbers will become the middle rational number of the given two rational numbers. So now the rational number between 2 and 3 is 2 plus 3 by 2, which is equal to 5 by 2. So then we can write it as, see this one. So 2 is less than, 5 by 2 is less than 3. Okay. Now, is there any other rational number between 2 and 3? 5 by 2 ఒక్కటి మాత్రమే ఉందా, ఇంకా వేరే రేషనల్ నంబర్ ఏదైనా ఉంటుందా? Let us see. Now I am taking the average of 2 and 5 by 2. That is 2 plus 5 by 2 by 2. Here nothing is there, it is 1. So here I am having LCM is 2. This is 4 plus 5 by 2, which is 2 by 1, that is 9 by 2 into 1 by 2, which is equal to 9 by 4. Yes, this is another rational number between 2 and 3. Now we can write it as 2. Now this is the rational number. This 9 by 4 is in between 2 and 5 by 4. 2 is less than, 9 by 4 is less than 5 by 2, and it is 3 is less than 3. That means here we have two rational numbers between 2 and 3. Is there another rational number in between these 2 and 3? Yes, there is another rational number also is there in between 2 and 3. How to find out? By taking the average of 2 and 9 by 4. We can find out another rational number. And in the same way, by taking average of 5 by 2 and 3, we can find out another rational number. By taking the average of 9 by 4 and 5 by 2 also, we can find out another rational number. That means 2 in between so many other rational numbers are there, and also in between also we have so many other rational numbers are there. So like this there exist infinite number of rational numbers are there. Can you believe this? Yes, we can believe. There exist infinite number of. So here there exist infinite number of rational numbers in between any two rational numbers. So if they ask the some blank like this, how many rational numbers are there between any two rational numbers? Now we can say that there exist infinite number of rational numbers are there in between any two rational numbers. So this property is called as the density property. What we call it as? Density property of the rational numbers. This is only the property which is especially only the rational numbers are having this property. So before what we have learnt, closure property, associative property, identity, these are all belongs to, some properties are belongs to all the natural numbers, whole numbers and integers, but only the density property is belongs to only for the rational numbers. Okay, so now let us see one more example. Find a rational number between -2 and 3 by 4. Okay, so we know that if a and b are any two rational numbers, then a plus b by 2 are is the rational number between 2 and this a and b. Now apply that one, that is so a plus b by 2. So in place of a we are having -2, and in place of b we are having 3 by 4 by 2. And here nothing is there, it is 1. The LCM for 1 and 4 is 4, and it is -8 and plus 3. Then we are having -5 by 4 and by 2, which is equal to -5 by 4 into 1 by 2, which is -5 by 8. So the rational number between 2 and 3, -2 and 3 by 4 is minus 5 by 8. Okay. So like this we can find out the rational number by using the formula a plus b by 2. So if I am asking only one rational number or two rational numbers or three rational number, then we can apply this formula. If I asked find any 10 rational numbers between 1 and 4. Here I am asking 10 rational numbers. Okay. So how to find out this one? We know the formula, that is we can find out any of the rational number by using the formula a plus b by 2. So we have to apply the a plus b by 2 formula, then we will get one rational number. After that, for that result we have to apply the once again a plus b by 2 formula. Like that, how many times we have to apply here? We have to apply 10 times. It is easy, but it will be a time taking process. Is it correct or not? So it is taking so much of time, but within very less time we can find out these 10 rational numbers. So by using another method, let us see what is that. Okay, so how to find out? If you want to insert more number of rational numbers between any two rational numbers, what is the process? ఏం చేయాలి మనం ఇక్కడ అంటే, so here we have to take the first rational number, multiply and divide the same number with the same number. Here I am multiplying and dividing with 10. Then it is 1 by, that is 10 by 10. Okay, I am taking another number. I am also multiplying both the numerator and denominator with the same number. Here I am multiplying and dividing with 10. This is 40 by 10. And this is 10 by 10. And this is 40 by 10. Now can I insert 10 rational numbers between these two? Yeah, we can insert 11 by 10. 12 by 10, 13 by 10, 14 by 10, 15 by 10, 16 by 10, 17 by 10, 18 by 10, 19 by 10, and so on. This is 40 by 10. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, and one more, that is 20 by 10. So like this we can insert more, but they are asking only 10 rational numbers in between 1 and 4. So like this we can insert any number of rational numbers between any two rational numbers by using this method. Is it easy or not? Okay. So now let us see one more example. Insert any 5 rational numbers between 1 by 2 and 3 by 2. Here also we have to insert 5 rational numbers between 1 by 2 and 3 by 2. Here also take any sum of the number, that is here I am multiplying and dividing both the numerator and denominator. Here with 5 I am multiplying, that is 5 by 10, and here also I am multiplying and dividing both the numerator and denominator with 5. This is 3 5s are 15 by 10. So the first number is 5 by 10 and the next number is 15 by 10. So here I want to insert only 5 rational numbers. This is 6 by 10, 7 by 10, 8 by 10, 9 by 10, and 10 by 10, and so on, and we are having 15 by 10. 1, 2, 3, 4, 5. So we can insert any number of rational numbers between any two rational numbers by using this process. So, like this, we can insert any number of rational numbers. We can insert infinite number of rational numbers between any two rational number, and also this property, this is a special property, already I told, no, this property is called as the density property of the rational numbers. Okay, children, have you understand today's topics? So let us recall what we learned today. So we learnt about the representation of the rational numbers on the number line, and we learnt about the rational numbers, how to find out the rational numbers between any two rational numbers, and also the density property of the rational numbers. What is a density property? So there exist infinite number of rational numbers between any two rational numbers. This property is called as this is the special property which is having the rational numbers. Okay na? Have you understand this concept, Nana? Okay, thank you.